Hello there, we're in Calculus 2 and we're doing checkpoint 3.3 from section 3.1. Here we're asked to evaluate this integral x squared times sine x dx. So we're going to need to use integration by parts, and looking at this x, and by experience I see that we're going to have to do it a couple of times, but let's work it out first and see what happens, and then we'll take a look at not really a shortcut, but like a nice quicker way of doing it. First, let's do it using the regular integration by parts. We'll see that our u is going to be equal to sine, our u is going to be equal to x squared, and then our dv is going to equal to sine x dx. So we take the derivative of u, and we're going to get 2x dx. And then the antiderivative of v. Remember, the antiderivative of sine is negative cosine. And then we'll leave the plus c out for now. And then we will get u times v. So this is going to be x squared times negative cosine x minus the integral of v du. So this is going to be 2x times negative cosine x dx. Switch the order, but we get the picture. Now, before we get to this second integral, let's work things out a little bit. Let's throw a negative in front, move that negative in front, so we have negative x squared cosine x. And then we have a negative here and a negative here, so let's make this into a positive. And then we have a constant 2 that we can take out, and then we have x cosine x dx. Now, looking at this looks like another integration by parts, so let's work on that. We'll let u equal to x and dv equal to cosine x dx, and then so du is equal to dx, which is always good. The antiderivative of cosine is positive sine x, so our v is equal to positive sine x. Therefore, we will have here a 2 times, and I want to put this in big parentheses because I know that the 2 has to be distributed out to the terms that's coming. We have x times sine x minus the integral of sine x dx. All right, and if we want to do this right here, the antiderivative of sine is negative cosine x, and then we'll throw the plus c out. So if we let this cascade down, now the 2 technically goes to the plus c, but then I'll put a sub 1 here, and then we'll eventually have a plus c that's going to be just a regular plus c. We'll see how that works out in the end. All right, I'm just going to copy that, or do a little ditto here. And so, well, final answer is going to be negative x squared cosine x, and here let's distribute the 2, so we get 2x sine x, and then the negative sign that comes up, the antiderivative of this is negative cosine, and so that negative and the negative will become a plus, so that's a plus, and then there's a 2 here, cosine x, and then plus c. So this is slightly different from the c, but it's still a constant whether you multiply it by 2 or not. So I'm just going to put a plus c here, and put a c1 here to make it a little bit different. Anyways, this is your result. But I wanted to show you another way of approaching this. So let's first rewrite our integral. Say we're integrating x squared times sine x, and if you have a feeling that this is going to take more than one turn of integration by parts, then there's a nice kind of chart way of doing it, columns and charts. So what we'll do is we'll create a column for u and a column for dv, and then this is going to be the integration of parts substitution that you'll be doing. So at first, you're going to have an x squared for the u, and then you're going to have a sine x for the dv. And we'll leave the differentials out for this particular method because we're just going to know that we're going to be taking antiderivatives and such. So on this side, you're going to take derivatives. And so let's take the derivative of this. We have 2x, and then we have 2, and then we're going to have 0. And that's essentially where we want to get to in the end. Now, on this side, you're going to take integrals. And the antiderivative of sine, again, was negative cosine x. The antiderivative of cosine is positive sine, but there's a negative there, so let's keep that negative. And then the antiderivative of sine is negative cosine, so it's negative and a negative cosine. This will be a positive cosine x. And we'll stop here at the level of 0. And then how are we going to get a result? So we're going to get a result by multiplying these things in a diagonal and multiplying them with a particular sign. So the first one will be a positive sign. You're going to multiply these two with a negative sign, and then you're going to multiply these two with a positive sign. And everything else would be 0, so there's nothing else to do. Okay, what does that mean? That means this thing should equal to, your antiderivative should equal to this thing with a positive. So we can put a plus here, but it's not going to be important. And then we'll just say this is going to be x squared times negative cosine x. So I'll just switch the order to make it look a little neater. And then here we have a negative coming up, but then there's a negative sign there which will eventually make that positive, and then we have 2x sine x. And then finally we have a positive here, and everything's positive, so we don't have to change the signs anymore. We got 2 cosine x. And then that's the end, so we'll tack on a plus c since this is an indefinite integral, and we'll see that we got the exact same result as we did from before. Okay, all right, I hope that helps. Good luck.